Hello, and welcome to Algebra 1 Honors. Today we're going to be starting Chapter 8, and this will be Lesson 8-1, Equations in Two Variables. Okay, before we start with equations in two variables, let's review what an equation in one variable is. All right, if I had this 2x plus 6 equals 12. You can see that I have one variable here, which is my x, and we're going to solve for x. We're very familiar about doing this type of problem. Okay, in this case, I subtract 6 from this side, subtract 6 from this side, and I end up with 2x equals 6. I divide by 2, and I get one answer, x equals 3. Okay, now, sometimes when you have two variables, you get one answer, or you may get more than one answer. And what does it mean when I have two variables? Let's look at this, for example. Okay, let's look at this one. 4x plus 3y equals 10. Okay, as you can see, I have a x variable and a y variable. Okay, now to solve this, we're going to use what I call a table. Okay, and we're going to make our table like this. We're going to put our x variables here, and we're going to put our y variables here. Now, the thing we're going to do with our x variables are we're going to randomly choose variables. What is the easiest variable to choose? It's 1. Okay, so if I choose 1 here, x is 1, I'm going to end up with 4 times 1 plus 3 times y equals 10. This will come out to be 4 plus 3y equals 10. I bring my 4 over, and as you can see, I'm going to solve for y. 3y equals 6 divided by 3. My y will equal 2. So when x equals 1, my y is going to be 2. Okay? Now, what this problem, sometimes when you have a problem like that, they'll say, okay, give me only integers. Okay, if you have only integers, that means that you can't have a fraction. But let's take, for example, what if I call x equals 0? If I called x equals 0, and I came over here, and I said 4 times 0 plus 3y equals 10, this would cancel out, and I would get a 0 here. 3y equals 10. Well, when I divided by 3, I would not get an integer. I would get y equals 10/3, or 3 1/3. Okay? That's the answer for y. That's another answer for y. But sometimes you have to be very careful what the question asked you. If it asked you for all answers, then you got a big project to do, because there's lots and lots of answers that are going to satisfy this equation. But if they only ask for, maybe they'll say only the positive integers, only negative integers, okay? Or they'll give you a list, a set, and they'll give you a x and y value and say, does this satisfy this equation? Does it make it true? And then you have to plug them in and see if it does. Let's look at another example. Okay, let's look at another example. It says, state whether each ordered pair of numbers is a solution to what we just had up on the board, 4x plus 3y. 4x plus 3y equals 10. Now they're going to give us, let's say they give us 4 negative 2. Okay, give us these numbers. Our first one is always our x value, and the second one is our y value. Okay, and then they give us negative 2, 6. And then for the heck of it, they give us a fraction. They say 3 over 2, 4 over 3. 3 over 2, 4 over 3. Okay, so what they're going to say, and we're going to call this guy A, B, and C. Now they're going to say, which one of those is a solution? So what we have to do is we have to go back and we have to plug in the x value and plug in the y value and see if it makes our statement or equation true. In the first one, I have my x value is 4, so I'm going to have 4 times 4 plus 3 times negative 2. Does that equal 10? Well, let's see. We have 16 minus 6 equals 10. Yes, it does. 10 equals 10. So in this case, we're going to put a big check mark here. Yes, this one is a solution. Let's look at the next one. Negative 2. 4 times negative 2 plus 3 times 6. Does that equal 10? We have negative 8 plus 18 equals 10. Yes, it does. 10 equals 10. So this one also. And let's look at this last one here. If x is 3 over 2, so I have 4 times 3 over 2 plus 3 times 4 over 3 equals 10. Now, as you can see, 4 times 3 over 2, we can cross multiply because what this actually means is this. 4 over 1 times. Okay, and we can cancel out. 2 goes to the 2 once, 2, so this answer will be 6 plus, and the 3's will cancel out, and I'll have 4 equals 10. So as you can see, all three of these guys were solutions to this problem. Okay. All right, and sometimes you have a little harder, a little more difficult problems, but you do them the same way. For example, if you had x plus y equals 3. Okay, let's look at this. Sometimes it's easier if you flip it around so that your y value, your y variable is all by itself. And I'll show you what I mean. X plus 1 x plus 1 times y equals 3. As you can see, this is written in a different form than we're used to. Okay, but that's not a big deal. What we're going to do is we're going to isolate my y value, so it's going to be on my left side, and I'm going to bring my x value on the other side. So to do this, if I'm multiplying times x1, I'm going to divide x plus 1 here, and I'm going to divide x plus 1 here, and now what I'm left with is y equals 3 over x plus 1. And to find solutions for these problems, let's see, what does it say? Whole numbers. Okay, whole numbers. It says solve for whole numbers. Whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and on. So those are the only numbers that we're going to look at. All right, so what we're going to do here is we're going to make our x and y chart. Here's my x value, y. So I'm going to start with 0 for x. If I put a 0 here, 0 plus 1 is 1, 3 over 1, my answer will be 3. Are both of those whole numbers? Yes, they are. So that's going to be a solution. All right, let's look at 1. If I put 1 for the value of x, I'm going to have 3 over 1 plus 1 is 2. have 3 over 2. This is yes. Is this a solution? Is this a whole number? No, because it's a fraction. Okay, so this is not going to be a solution. How about 2? Let's put 2 in there. If x is 2, I'm going to have 3 over 3, which is 1. Is that a solution? Yes. And if we put 3, we're going to get 3/4. And as we keep going on and on and on and on, we're always going to be getting a fraction. Okay, so the only solutions to this are this one here and this one here. Let's just take 5 for, let's just take 8 for example. Okay, so 8 plus 1 is 9. Okay, if this is 8, 3 over 9 is 1/3. That's still not a whole number, so that's no. So the only two are these two. Okay, and then the last thing that you need to know is this. Sometimes you get an equation of two variables in a word problem. And this is what we're going to have. And you solve it the same way. There could be, and there usually is, more than one answer. Okay, that's what makes these variable problems in two variables most difficult. Because we're so used to getting a answer and being so happy, and then we're done with our problem. Not in this case. Let's look at this. It says that Dawn spent $13 on pens and notebooks. Okay, well, let's make a little graph. Okay, let's put pens. Okay, we got pens here, and we have notebooks. Okay, we'll go like this. Okay, what variables could we use for pens? How about a P? We'll use a P for pen and an N for notebook. Okay, now it says something else. It says the pens cost $2 and the notebooks cost $3. Okay, so we're going to have something up here say cost. The pens cost $2, notebooks cost $3, and our equation will be, or our parts are variables for our equation. Variables for our equation will be 2 times P. So, if we buy 1 pen, it'll cost $2. If we buy 2 pens, it'll cost 4. 3 pens, it'll cost 6. So it's 2 times the number of pens we buy. And that's how much the cost will be. If we have $3 a notebook and we buy 1 notebook, it'll be $3. If we buy 2, it'll be 6, and on and on. So over here, it's going to be 3N. Now it says one last thing. You have to read these very carefully. It says Dawn spent $13 on pens and notebooks. Okay, so pens plus notebooks are going to cost $13. But how much does a pen cost? Pen costs $2. So we have to put this 2 here. 2 times the number of pen is going to be money. And over here we have to put our 3 here. 3 times. Okay, so that's our equation. Now when we solve it, we're going to do the same thing that we did before, and we're going to graph it. And just to make things easy, I'm going to graph, I'm going to pick the magic number that's going to be successful for this. Okay? Let's pick 1. Let's pick 1, 2, and 3. Okay, so if x is 1, 2, and 3. Okay? Now, what your book wants you to do is they want you to, we can do it this way, no problem, but what they want you to do is isolate one of the variables. Okay? I'll show you both ways you can do it. The first way is to isolate one of the variables. Let's isolate n. All right, if I'm going to isolate n, I'm going to have 3n here equals 13 minus 2p, and I'm going to divide everything by 3. Okay, so my n value will be 13 minus 2p divided by 3. All right, let's let's plug in our n values. Instead of x and y, we're now going to make it n and p. Okay? It's the same procedure. All we're doing is changing our variables. All right, we're going to say, what if n is 1? What if n is 2? What if n is 3? All right, let's look at it. If n is 1, we're going to get, if n is, oh, I did a bad one. Let's flip it around a little bit. Well, that's all right. Well, let me back up just a second. I want a variable of p, not n. Okay, so what I'm going to do is, I'm going to send n over. I'm going to have 2p here equals 13 minus 3n. And divide everything by 2. And we have p equals 13 minus 3n over 2. Now we're going to plug in our n. You see this one here, 3 times n is 1 is 3. 13 minus 3 is 10, divided by 2 is 5. So if I buy one notebook, I can buy 5 pens. Let's plug in 2. Okay, 2 would be 13 minus 6 over 2. 6 of 13 is 7 over 2. I could buy 7 over 2 pens, or 3 1/2 of a pen. The problem is that stores don't sell half a pen, so this answer we know can't be true. Let's look at the last one, number 3. 13 minus 9. 13 minus 9 is 4, divided by 2. I'm going to get a 2. So the two answers that fit here are, I could buy either one notebook and 5 pens, or 3 notebooks and 2 pens. Okay, and that's basically all this is, lesson 8.1, equations and 2 variables.